You wish to test the following claim at a significance level of alpha equals 0.10. The null hypothesis is that the means of your two populations are equal. The alternative hypothesis is that the mean of your first population is less than the mean of the second population. You believe both populations are normally distributed, but you do not know the standard deviations for either. However, you also have no reason to believe that the variations of the two populations are not equal. So you obtain a sample from each with X bars and sample standard deviations for each. And we're going to perform this hypothesis test. We're going to get the test statistic for the sample, the p-value for the sample, and then we'll compare the p-value to alpha, which will lead us to a decision and a conclusion. So to do the hypothesis test, we're going to go to the calculator, and we are going to move that out of our way. So on the calculator, we'll do tests, and we'll do a two-sample t-test, which is choice number 4 here. And we have stats, not data. Data would be if we had it in lists. So we have stats here, and I will enter those in quickly. So I've entered in all of our sample data for both sample 1 and sample 2. We're down to choosing which hypothesis test to do. So our hypothesis test says that mu1 is less than mu2, so we'll arrow over to that one, and we'll select that one. We'll arrow down from there, not pooled, and we will calculate. And you'll see we get a test statistic T of 3.094 and a p-value of 0.0017. Let's come over here. The test statistic that we just got was negative 3.094, and the p-value was 0.0017. Okay, so now we can look at our data and draw decisions and conclusions from that. So our p-value at 0.0017 was less than alpha. When the p-value is less than alpha, that tells you that the probability of getting the data that you got, if the null hypothesis were true, is smaller than the significance level that you have given it. In other words, it's less likely than you are comfortable with. And that leads you to a decision to reject the null. And then for our final conclusion, we need to look at this and see which one of these conclusions is talking about rejecting the null in favor of the alternative hypothesis. And that would be the third one, that the sample data support the claim that the first population mean is less than the second population mean, because that's what the alternative hypothesis is, that claim that the first is less than the second. The sample data support it. We have rejected the null hypothesis in favor of that hypothesis. So there is our answer, that the sample data support the claim that the first population mean is less than the second population mean.